Hey guys, welcome to your fourth flip. Today we're going to talk about the role of electrons and how we show them. So we've been talking a lot about, the atom in the past, and we've been talking about chemical reactions, chemical changes, those types of things. So now we're going to move into the role of electrons and sort of how we show electrons, where they are, and how they move. And the reason for this and where we're going with this is we're going to talk about two different types of compounds and how different chemical reactions occur. And electrons are key for this. Electrons are the most important part. They're the things that move from, are either given away or taken by an atom or shared between two atoms. And that whole process creates chemical reactions and allows us to see those chemical changes that we've been talking about. So every time we see a chemical change and those signs of a chemical change, a chemical reaction has taken place. And all that chemical reaction is electrons moving and changing the properties of things. Okay? So here we're going to talk specifically about the role of electrons. So to review quickly the atom, you've got the protons that are in the nucleus, that positive charge, and the number of protons determines the element, right? Hydrogen has 1, helium has 2, lithium 3, and so on. The neutrons, right, they're also in the nucleus. They create that balance. They allow the atom to be stable. Okay, they're neutral, same mass as the proton, they're identical to the proton, except they have that neutral charge instead of a positive charge. Okay, and then last but not least, the electrons. Okay, they've got that negative charge. They're involved in bonding, and then they're found in these clouds. And we're going to represent those with orbits and circles for today. But generally, they're found in these clouds of probability where we think they probably are, and they're around the nucleus. And again, they're the key part of bonding, and that's where we're going with this. Okay, so what are chemical reactions? They're basically they're driven by this desire of atoms to have these full shells, right? So we talked about the shells around the nucleus that electrons fill, and they want to fill that outermost electron, that outermost energy level. Okay, and again we've shown remember we played around. We saw that the first shell holds those 2 electrons, and that's why the first period, if you remember, hydrogen and helium, there are only 2 elements in there because that first shell only holds 2. Then if you go to the second row, the second period, that represents the second shell, and it holds 8 electrons. And again, you see 8 elements across. The third shell will hold another 8 electrons. And again, you see 8 elements as you go across. From there, it starts to get more complicated. You start seeing 18 in there, 32. These are things you're going to learn a little bit more about as you get older and you start taking chemistry in the senior grades. But for our purposes so far, we're just going to deal with sort of those first 3 periods, the first 3 rows, right? And dealing with trying to fill the electrons, because that's the goal here for all those atoms. And that's why reactions happen. They're either giving electrons, taking electrons to fill the shells, right? So we're always going to fill those energy levels from the inside out. So here's a diagram of phosphorus right here. Okay? And this is a Bohr-Rutherford diagram of phosphorus, and I'm going to show you how to draw those in a minute. And you can see the electrons on the outside, sort of the 2 on that first energy level, then the 8 on the second energy level, and then 5 in the 5th. Okay, so 5 valence electrons. So that's valence electrons, or electrons in that outer shell, just to review again. Right, so 5 valence electrons, outer shell electrons, and it wants to have 8. Okay, so it needs to add 3 electrons to fill that and be happy. So when it does that, it takes on a -3 charge. Because electrons are negative, you end up with 3 more electrons than you have protons in the middle, right? Because generally that neutral atom has the same amount. You add 3 negatives, it becomes a 3 negative charge. One way to simplify the whole process and to start showing these things is Lewis diagrams. And so a Lewis diagram just simply shows the number of valence electrons, so the electrons in the outer shell. So this is phosphorus, this is neutral phosphorus, right? Because it still has the 5 valence electrons. So you just draw the P, and the number of valence electrons are out the outside. And again, I'm going to show you how those work in a minute. The key thing here is showing you now, right? 1, 2, 3, 4, 5 valence electrons for phosphorus. It's very clear now that phosphorus would like 3 more to fill that shell. So on the other hand, you've got lithium, okay? And again, here's a Bohr-Rutherford diagram of lithium and a Lewis diagram of lithium, okay? It has 1 valence shell, or electron in its valence shell, right? You've got 2 in the first shell, we fill it first, then we go to the second energy level, and it has 1. It would like to have 8, So 7, I would have to gain 7 electrons to have that outer shell. What it would rather do, and what's way easier, is just to get rid of this 1 extra electron. So what we do is it just gives it up. And that's why you see something like lithium would love to bond with something like chlorine or phosphorus over on the right-hand side of the periodic table, because those elements tend to want to gain an electron. And so lithium gives up that 1 electron really easily. It's just left with that 1 inner shell, and it's full. And so it's happy. And now it becomes a +1 ion, because it has 3 protons and only 2 electrons. So 3 pluses, 2 minuses, you get that 1 plus. And again, beside it, you see the Lewis diagram here for lithium. Okay? So that's the quick sort of rundown of the role of electrons. Now I want to show you how we demonstrate and how we illustrate this. So let's start with phosphorus again. So we're going to do a Bohr-Rutherford diagram. And the Bohr-Rutherford diagrams, this will erase, there we go, are a great way to demonstrate the entire atom. What does the whole atom look like? From the nucleus right out to the valence shell, that outer shell of electrons. So what you'll do, you'll use your periodic table with these types of things. So let's go back to my periodic table. All right, and I'm just going to see. So I would always find phosphorus, be the first thing I would do in this case. I see that it has an atomic number of 15, which means it has 15 protons. I see that it has a mass of 31, so it means it's going to have, we'll have 15 protons plus I don't know how many neutrons to give me 31 atomic mass. So we'll have to do a little bit of math there, right? 31 minus 15 will give me 16 neutrons. And I know it's we're going to go with it's a neutral atom, so it's going to have 15 electrons. Remember, electrons have the same number of electrons as you have protons. Okay, so we're going to take that information, okay, and we're going to say we have atomic number 15, so have 15 protons. Protons go in the nucleus, so let's draw a nucleus around it. And I also know that I have, because I did my math before, right, the 31 minus 15 gave me 16 neutrons. Again, atomic mass, and this is the atomic number. Okay, so 16 neutrons that go along with it. And now I'm just going to draw in my electron shells. So the first shell, and let's actually just make my nucleus a little bit smaller, and I'll fill my outer shell. Okay, so the first shell, remember, just 2 in the first shell. And if you're ever not sure, you need to remember, and always go back to the periodic table and just count. 1, 2, right? This represents, this whole row represents the first shell. And the second shell, we count those out as having 8. Right? So the periodic table gives you hints on how many of those things are there. So 2 in the first shell, right? We go back, we see that 1, 2, 3, 4, 5, 6, 7, 8 in the second period. So that means I can put 8 in that second energy level. And I'm going to pair them up. And why we do that, that's something we're going to learn a little bit later. But it's a good habit to get into now. So now I'm up to 2, 8, 10 total electrons. Remember, I needed 15 electrons. So I need to add another shell of electrons. So I'm going to do that. Okay. And now I have 5 left over. So I'm going to fill the 5. So I'm going to put my 4 in at different places. And then a 5th. So now I have my total of 15 electrons. 1, 2. Plus 8 is 10, plus 1, 2, 3, 4, 5 more. And that's your Bohr-Rutherford diagram for phosphorus. Okay? The Lewis diagram now simplifies the whole process. All we're going to do for the Lewis diagram is we're just going to take the atomic symbol, so again for phosphorus is P, and now we need to know how many valence electrons does phosphorus have. So if I go back to the periodic table, I can always figure that out by counting across my period to the number that it has. So 1, 2, 3, 4, 5. Because remember, the group number tells us how many valence electrons are in a certain atom. So again, this first group is 1, second group is 2. We ignore these guys because they're funky. They bother us. 3, 4, 5, 6, 7, and 8. So since phosphorus is in that 5th column, the 5th group, it must have 5 valence electrons. So again, we're going to put 4 around the outside and pair up the 5th one. And that's a Lewis diagram right there. Really easy, really straightforward, and it's going to come in handy when we talk about ionic bonding and even covalent bonding later on, because it just talks about those valence electrons, which are the ones that do the bonding, and they're the important ones. Okay? So make sure you take some notes on this, whether you use this page or Cornell notes, which I would suggest sort of helps organize all these things. Try to do this, right? Go through the Bohr-Rutherford diagram for phosphorus. It's here. You can go to the Role of Electrons note in your OneNote to sort of check your answer, but go through the process and practice. Make sure you answer the question for the flip, and then we're going to come back into class, all right, and we're going to do some practice on this. So you guys get a chance to practice Bohr-Rutherford, Lewis diagrams. We'll get up on the whiteboards and practice a little bit of that. Okay? So good luck. I hope this goes well, and we'll see you in class.